Okay, if y'all wouldn't mind just for a second, if everyone could be really, really quiet. Everyone? Quiet, please, just for a second. Got to make sure that the microphone's not picking up. Okay, that looks all right. I was having trouble finding a radio frequency to work with. So, all right, I got a new microphone, so I hope this doesn't turn out to be a complete disaster today. Hopefully it doesn't come out too loud or too quiet on the video. We'll see. Everybody has handed in their take-home. Anyone else? Last call. Remember, it's due at the beginning of class, not 5 minutes, 10 minutes later. How did that second one go compared to the first one? Did y'all feel a little more comfortable with it? I was over the weekend, I was like, well, you know, if they're turning in a mini exam, then that means it must be time for the next one. And I was like, all right, are they ready to do the next one? I looked at it, and you can actually do everything on this before I even start today's material. So this is up through, this is going to finish off chapter 10. So this is up through, actually the concepts on this one are just 10.7 and 10.8. So it's 4 problems, that's it. It's due a week from today. I've posted this online already in both the PDF and CDF format. Sorry? Yeah, go ahead. There y'all go.
That escalated so quickly. I don't call you Oh yeah.
Thank you.
Off the top of my head, I think it's towards B.
You ready to go? I'm not going to go over the solutions for that second mini exam. We're just going to get right into today's material. We left off last time, we had just barely got our feet into chapter 11, right? And we were talking about 11.1, which was functions of several variables. And we realized that if you have 3 variables in an equation, and you can solve for z, then you can always write z as some function of x and y, right? So z can be looked at as some function of 2 variables, x and y. And if you are to do this, it will draw what in 3-dimensional space? A surface, right? This is going to draw you a surface. Curious to know how you feel about this. Do you think we could do something like this? Or something like this? Yeah? All of these have something in common. 2 inputs, 1 output. 2 inputs, 1 output. If you look at z equals f of xy, the domain is the ground, right? The xy plane, and well, some part of it. And it graphs these points that come up and become this surface that's kind of waving around above the ground, yeah? If you do it this way instead, then you're still going to get a surface, but now your ground is actually the yz plane, which means it's kind of like a wall, right? In the room, it's kind of like one of the walls, and then your surface is coming out this way, and your sheet is actually like that instead of like this. Does that make sense? Sideways. And then if you do something like this, oops, sorry, this should be what? Y. Then your y coordinate is a function of x and z. And again, the xz plane would be your domain, and then the y coordinate would come out and give you your surface. So this is a traditional surface sideways, and then this one sideways again, right? Makes sense? That's going to come into play later on, all right? All right, so we are going to start today by talking about a surface here. F of x equals x natural log of y squared minus x. And we want to try and determine, first of all, the function's value at a point, 3, 2, then determine the domain and sketch the domain in two-dimensional space, and then determine the range of the function. Okay? So let's start with part A. We are going to find f of 3, 2. Before I forget, not only am I doing the microphone a little different now, I am also going to record at 1080p instead of 720p, which means that it's going to be 4 files when you go to look at it. So today, later on today, it'll be 4 files on YouTube, if you are going to look at it. And then what I'll do is I'll come in later, and I can use YouTube to compress them down to 1 file. But that usually will take about a day to happen. So initially, it'll be 4 files. Within a day, it'll be one video. All right? Just FYI. So all we do here is just replace x with 3 and y with 2, right? So x is 3. We get 3 natural log. Y squared is 4. Take away 3. And what does that give you right there? 0, right? Because natural log of 1 is 0. So this gives you 0. Now, there are certain things we cannot plug in, right? Someone give me an example of an ordered pair that I could not plug into this function.
3, negative 2.
3.
No, I mean, hang on. Never mind, I take that back.
4, 2. Yeah, 4, 2 wouldn't work. I'm at 3, 0. Would that give you 3 natural log of what's y? 0? So 0, take away 3, that would give you natural log of a negative number, which you can't do. Right? So there are certain points that are okay, certain points that aren't. So we're trying to find in this problem the domain for part B, which is give me a graphical representation of all of the points that are allowed. Right? So what are the things we have to concern ourselves with for part B? What are the things that would cause us a problem when you look at that function? Yeah, the natural log function cannot handle 0, can't handle negative numbers. So we need the thing inside of the natural log function, which we call the what? The thing inside of a function is called the argument. You remember hearing that before? The argument of a function is the thing that's being plugged in, what's being evaluated. So what I need for part B is that the argument of the natural log function not be 0 and not be negative, which means it needs to be greater than 0, strictly greater than, right? Then I'm guaranteed that the points will work. So all points that satisfy this quadratic inequality would be representative of my domain. Questions? I need that to be true, right? Now, if I were to come in here and say, all right, well, I don't like inequalities, let me first just switch this over to an equation, then I hope that we could all sketch that, right? That's a parabola, but it doesn't open up, right? It opens sideways. So it's going to look like this, and it would go like this, wouldn't it? No, I'm going to draw it for right now. This is y squared equals x. Now, am I actually allowed to pick points on this parabola? Like if I pick a point on this parabola, am I allowed to plug that point into my function? Well, this is equality, isn't it? If you're on this parabola, you have this equation. What do I want? I want this, inequality, right? I don't want them to be equal. So points that satisfy this, I don't want, do I? So I don't want to draw this solid. I want to draw it dashed. Understand? We don't want to include all the points. So it's a dotted parabola. And then the question is, which side of the parabola are all your other points in your domain? The stuff over here or the stuff out on the outside? And how do we normally go about determining that? Just test a point, right? Just pick a point that lives in one of the regions and test it. So a good point would be something like, what's the point here? 3, 0? Does that live over here? Test that point. Oh, we did. Does that point work? No, it's undefined. So anything in this region shouldn't work. You could go and keep checking others. Now, a point that did work was 3, 2, right? And that point, 3, 2, can't tell, but it's outside of here. So what I know is that my domain should be on this side of the parabola. Make sense? There any questions? I've graphed it in two-dimensional space.
So that's the domain?
That is the domain of the function, visually. But then students will ask, well, how do you write that not visually, right? Like, how would you actually represent that set of points without the picture? Well, here's how you would write it. Call this set builder notation. You could say the set of all x's and y's, so all ordered pairs. Then we use a bar to say such that. So we're saying, hey, what's the domain? Well, it's all the ordered pairs such that y squared is greater than x. Done. That's it. That's the set notation of this shaded set. Everyone does understand if this had been equals, that would not be dotted, right? Okay. What about the range, part C? The range is a little more involved because the range is the output, isn't it? What comes out of that function? What do you think? What comes out? Do you understand why it's harder to do? Pardon me? This is the z, right? What we're trying to figure out is there some restriction on z, like this only spits out positive answers, or it only spits out answers between 1 and 5, or something like that. So let's look at it. Do you see any possible issues? Could we get positives to come out? Well, if x is a positive number, that should be positive. We know the natural log spits out both positive and negative numbers, right? Think about your natural log function. Looks like this, doesn't it? That's what natural log looks like. That's natural log of x. So the natural log spits out positive numbers and it spits out negative numbers, right? The question is, to get everything out, negative infinity to infinity, can you make this right here all values between 0 and infinity, not including 0? What do you think? Let me just fix x to be 1. Okay, if x is 1, then what does that function up there turn into? F of 1y equals natural log of y squared minus 1. Do y'all agree? Yeah? Still there? Yes? That's the way that would look. So this is now a function of just one variable, right? Y? Can you get y, could you get y to be 0? Let me ask you that. Could you actually get the input of this function to be 0? You're not allowed to do it, but could you do it? Could I let y be something that would make that 0? If y was 1, right? Okay, so if I pick a y that's just a little bit bigger than 1, this number will be a little bit bigger than 0, right? So I can create an input that's a little bit bigger than 0, which means it'll spit out a huge negative number, won't it? Can I keep on doing that and keep on plugging in things for y that are going to get me all these positive numbers? Yes? Right? Another way to look at it is, what does y squared minus 1 look like? Well, it's a parabola, right? What's the lowest value on this parabola? Negative 1, right? Negative 1 all the way up to infinity. So I know that I can get any number in here between negative 1 and infinity. And the natural log function from 0 to infinity draws the whole thing. Are y'all following me? What's the range of this function? Maybe y'all aren't getting it. I'm hearing 0 to infinity, 1 to infinity. Negative infinity to infinity, yes. Look, don't look at this as natural log of x, okay? Just look at this as the natural log function. This is the input, right? This is the output. If I have a natural log function, you plug a positive number in, it's going to spit something out, yes? This right here is a natural log function. This input, you just told me this input, no matter what values of y I pick, this input here has to be between -1 to infinity, right? I can make this anything between -1 and infinity. So the input of a natural log function that you have here can be anything between -1 and infinity, but any natural log function, to draw the whole thing, has to just go from 0 to infinity, yes? So you're going to be able to do that, right? You'll be able to produce every positive number, which means it'll create every possible outcome from the natural log function, which dives down to -infinity and goes up to infinity. So the range is, you could say all real numbers, you could say -infinity to infinity. The range is a harder question to answer.
You know, on the graph, it's going negative 50.
Well, this graph tells you that, but the question, this is the thing I think that people are getting hung up on. Yes, of course, this graph, the range of this graph is -infinity to infinity. But the question is, can you create every input? Does this create every input? Y squared minus 1. So let me show you an example. If I change this to +1, is it going to create everything? Can you get 1/2 out of this? Can you plug in a y and have it spit out 1/2? No. The smallest this is going to be is what? 1, right? So you're not going to be able to get 1/2 out. The smallest we just said will be 1, right? So the smallest input you're going to have is 1. Anything bigger than 1 you'll be able to plug in, so you're going to get this part. If that were the problem, if it were, which it's not, then the range would actually be from 0 to infinity. 0 to infinity. It's subtle. I hope y'all are catching it. All right. Where's my little spray bottle? Let me go grab that. Shall we look at it? Here's the actual function. It's a surface, right? I'll move it around so we can see it a little better. It's got this weird thing happening. Do y'all see that weird sort of, like someone came and tore it? Someone came and tore our sheet right in here. It's real jaggedy. You see that? That's actually the computer freaking out. Okay, the computer doesn't know what to do there. What's happening is you're getting an asymptote. Just like the natural log function dives down to -infinity, like you can't keep drawing forever, right? So this is the computer trying to draw the surface. It's diving down to -infinity, and it's having a hard time dealing with it. So at some point it just gives up, starts cutting the picture off, and you get these jagged edges on it. All right? So if I look at it from the side, do you see how we're diving down, right? These look like logs, don't they? Each of these look like log functions. That's like a log function. Right behind there's another one, another log function. So if I hold my x value constant, like I did, right? I held x at 1, and I had a log function. That's exactly what happens here. If I look at it from the top, so I'm standing up above this, and I'm looking down. It's pretty obvious, you know, with our domain, isn't it? We can see the domain clearly. What about this one? Okay, let's see if we can make sure I plug that in. I'm all paranoid because on Friday, you'll see if you watch the homework solutions for one of these sections. I had my new microphone. I was all happy about it. I did the whole video of the homework solutions. I forgot to plug the little 3.5 millimeter jack into the camera. So the audio is the audio from the camera, and it sucks, and I was all pissed off, man. But, all right.